Imagine a country roughly the size of a mid-tier American state, squeezed on all sides by hostile neighbors. And instead of a modern tank fleet, its armored core is basically a traveling museum of military surplus. That was Israel's reality by the mid-1960s, and the way out looked impossible. But Israel did something even the major powers hadn't managed. With zero history in tank manufacturing, it built a machine that completely rewrote the rulebook on crew survivability. This is the story of how desperation gave birth to one of the most unconventional combat vehicles of the 20th century. When the State of Israel was established in 1948, its armored forces were a mess by any standard. The first fighting vehicles operated by the young army were French Renault R-35s and Hotchkiss H-39s, light tanks that were already obsolete before the Second World War broke out. Over time, that scrap heap grew to include British Cromwells and American Shermans, sourced from wherever they could be found. Arms dealers, barter trades, and the occasional quiet lift from European storage depots. The logistics officers were tearing their hair out because every type of tank demanded its own spare parts, its own ammunition, its own trained mechanics. It wasn't an army. It was an armored petting zoo. By the mid-1950s, the Israelis had acquired more modern French AMX-13s, and by the early 1960s, the Israel Defense Forces had around 400 American M48s and roughly as many British Centurions. The tank fleet was still a patchwork, and military leadership understood perfectly well that this couldn't go on. Israel needed a single main battle tank, heavily armed, well-protected, and capable of covering every operational requirement. Two paths were on the table.
First, design something from scratch. Second, buy proven hardware from abroad. Given that Israel had never built anything more complicated than trucks, the second option looked far more realistic. Negotiations opened with the Germans, the French, and the British. The West German Leopard 1 was mobile enough, but its protection level left something to be desired, unacceptable for a country in a permanent state of war. The British Chieftain, on the other hand, genuinely caught Israel's attention. In 1967, two chieftains arrived in Israel for comprehensive trials. The British had no idea what their tanks were about to go through in the Negev desert. Israeli tankers drove those chieftains like they were trying to break them on purpose, launching over dunes, forcing their way through rocky riverbeds, running the engines non-stop for days in 40-degree heat. Within a few months, both tanks were so thoroughly wrecked that the British had to ship over two more just to continue the evaluation. By autumn 1968, the second pair was equally destroyed, but the Israelis had gathered everything they needed. Israel was ready to place a major order for chieftains with modifications for the Middle Eastern theater. The British Ministry of Defense was practically rubbing its hands. This wasn't just a tank sale. It was contracts for spares, tooling, crew training, and technical support stretching years into the future. British industrialists were already counting the profits when the Foreign Office stepped in and killed the deal, declaring that Israel was not a sufficiently peaceful state to receive offensive weapons. It was a gut punch. The Germans were out because of inadequate protection. The French had imposed an arms embargo on the region after the Six-Day War.
The Americans were deep in Vietnam and had no interest in sharing their latest developments. That left exactly one option: build it themselves. Building their own tank from scratch sounded like madness. Developing a modern main battle tank was the kind of project that took the Soviet Union or the United States years of work by massive design bureaus with generations of accumulated expertise. Israel had none of that. No experience, no time, and nowhere near enough resources. But with no other options left, they decided to take the risk.
The man who made the whole thing possible was General Israel Tal. He was no desk officer. Tal had fought against Rommel's Africa Corps with the British Army as a young man, served through the entirety of the Second World War, and then participated in every conflict the new Jewish state had faced since independence. By the time work on the new tank began, he commanded all Israeli armored forces and carried enormous weight with both the military and the political establishment. He was that rare type, someone who could fight a war and bulldoze through bureaucracy with equal effectiveness. On June 6, 1970, the Israeli Ministries of Defense and Finance received the findings of a feasibility study on developing a domestic tank. The document, prepared under Tal's direction, laid out a detailed analysis of every available option. The conclusion was unambiguous. Israel required its own combat vehicle, designed specifically for the conditions of the Middle Eastern theater. Ordinarily, a report like that would drift between government departments for months, collecting signatures and amendments. But Tal pushed hard. Just 2 months later, in August 1970, the project received full government authorization. By the standards of any bureaucratic machine, that was a remarkable pace. Tal formulated the requirements for the new tank personally, drawing directly on his combat experience.
The first and non-negotiable priority was crew protection on an unprecedented scale. Not just good armor, protection so thorough that tankers would survive even when the hull was breached. Israel was a small country with a limited population, and every trained crew member was an irreplaceable asset. Losing a tank was bad. Losing a trained crew was a catastrophe. The second requirement was firepower capable of defeating any enemy tank then in service. Third, the ability to operate effectively across the specific terrain of the Middle East: desert, mountains, and rocky plains. Fourth, and this was genuinely unusual for a tank, the capacity to carry infantry or wounded personnel inside the hull. And finally, despite all that protection, the machine couldn't be allowed to become a slow, lumbering target. The contract went to Israel Military Industries, and thanks to Tal's influence, the company received everything it needed to get started. Despite the engineers having no prior experience in tank design, progress moved at a striking pace. Less than a year after work began, a full-scale wooden mock-up of the future vehicle was ready. The mock-up was used to work through the general layout, crew positioning, and core design decisions. The next step was a metal prototype, and here the Israelis showed characteristic ingenuity. They cut up a Centurion, took the rear section of the British tank, and rebuilt it as the front end of the new design. The turret was also borrowed from the Centurion. The resulting hybrid looked strange, but it allowed engineers to test the components and systems intended for the production vehicle. A distinctly Israeli approach of working with whatever was at hand, rather than waiting for perfect conditions.
During trials of the metal mock-up, a serious problem emerged. The driver had originally been placed behind the engine compartment, but in that configuration, his field of view was completely inadequate. He simply couldn't see where he was going, which was obviously unworkable in a combat vehicle. The driver's position had to be moved to the left side of the hull, roughly following the layout used on the Soviet Mk.1. That single change cascaded into a series of other modifications, but ultimately made the vehicle considerably easier to handle. After the redesign, 2 full prototypes were commissioned. Hull production immediately ran into a problem typical for a young industrial base. Israel had no domestic facilities capable of manufacturing components of that complexity, so the hulls had to be ordered abroad. They arrived on schedule, but the turrets caused a delay. The Israelis had decided to build those themselves and, predictably, missed the deadline. Rather than leave the first prototype sitting without a turret, they temporarily fitted it with a turret from an American M48, and in that somewhat absurd configuration, the machine went out for trials at the end of 1974. Testing ran for nearly 18 months through 1976. The prototypes were pushed through every conceivable condition: desert runs, mountain passes, live fire in both directions, stress tests on every system in the harshest possible environment. In parallel, preparation for series production began that same year using the second prototype, now fitted with the Israeli-designed turret, as the production baseline. But the road from prototype to factory floor turned out to be far harder than anyone had anticipated.
Series production of the new tank became a genuine stress test for Israeli industry. The military insisted, reasonably, that the vehicle be built from components manufactured domestically. Depending on foreign suppliers in a country facing a permanent threat of war and potential embargoes was simply too dangerous. That meant hundreds of Israeli firms had to master the production of highly complex assemblies they had never worked with before. Final assembly was organized in a dedicated workshop at the Tel HaShomer military base, and the first vehicles were put together essentially by hand, with constant fitting and adjustment of individual parts. On April 26, 1979, the first 4 production tanks were formally handed over to the military. Nearly 3 years from the start of series production to the first delivery, a long time by most standards, but not surprising given that Israel wasn't just building a tank. It was building an entire industry from nothing. That same year, 1979, the vehicle was officially accepted into service under the name Merkava, Hebrew for chariot. By 1980, 80 tanks had reached frontline units, with production running at 10 or more vehicles per month. Total output of the first variant reached somewhere between 230 and 300 machines. Now for the technical side, because the Merkava was genuinely unusual in several respects. The hull was welded construction, but the front section was cast. The upper glacis plate measured 60 millimeters, the lower 90 millimeters, with slope angles reaching 65 degrees. Side armor was 50 millimeters, supplemented by external suspension components and side skirts that provided additional protection in their own right. The most distinctive feature of the entire design was the placement of the power pack. Unlike virtually every other tank in the world, where the engine sits in the rear, the Merkava's engine and transmission were mounted in the front of the hull. That layout was common on armored personnel carriers and infantry fighting vehicles, but almost unheard of on a main battle tank. Under a large hinged cover on the right side of the upper glacis sat the engine and transmission combined into a single, removable power unit. The reasoning was deliberate. The power pack served as additional protection for the crew. Any round that pierced the front hull first had to pass through the engine block before it could reach the men inside. That wasn't the end of it. Flanking the engine compartment on both sides were fuel tanks, which also served a protective function. A penetrating round would pass through the armor, then through the fuel tank, then strike a 30-millimeter armored bulkhead before it could reach the engine. On the surface, putting diesel fuel right next to a likely hit zone sounds reckless, but the Israelis had installed an advanced automatic fire suppression system that could extinguish ignition in fractions of a second. Behind the engine sat a second bulkhead, 35 millimeters thick, separating the power pack from the fighting compartment entirely. The driver was positioned to the left of the engine in his own armored capsule, with 35-millimeter walls equipped with 3 observation devices providing adequate forward visibility. That isolated placement significantly improved his chances of surviving serious damage to the vehicle. The turret was an unusual shape, compact by design, since combat experience had shown that turret hits accounted for a disproportionately high share of tank kills. The smaller the target, the better. Cast armor throughout at 65 millimeters, but that modest thickness was offset by the turret's small dimensions and complex geometry, which promoted deflection.
The trade-off was cramped working conditions for the crew. 3 men shared the turret space. The gunner sat to the right of the main gun, with a periscopic sight featuring 8-power magnification and a laser rangefinder. Directly behind him sat the commander, with a panoramic sight at 20 power and 5 observation devices. The loader occupied the left side and also operated the radio. A 60mm mortar mounted externally on the right side of the turret raised eyebrows among foreign observers. For most armies, it seemed like an odd addition, but it made perfect sense in the Israeli context. The mortar could loft rounds over dunes or rocky ridges to hit targets that were shielded from the flat trajectory of the main gun. The turret also carried machine guns for anti-infantry and limited anti-aircraft work. The rear of the hull deserves special attention. TAL's requirement for carrying infantry inside the tank had been taken seriously. A hatch in the rear hull opened into a dedicated compartment that could accommodate a small number of infantry, stretchers with wounded personnel, or additional ammunition and supplies. It wasn't a full-scale troop compartment like on an IFV. Conditions inside were cramped, but the ability to evacuate casualties under armor was considered invaluable. The main armament was the British Royal Ordnance L7 in its American-licensed variant, the M68, which Israel also produced domestically. The same gun equipped the West German Leopard 1 and most Western tanks of the period, proven, reliable, and well understood. The ammunition load was 62 rounds, distributed with careful attention to survivability. Only 6 rounds were stowed in the turret for immediate use. The remainder were carried in the hull in dedicated containers, 6 2-round canisters, and 11 single-round stowages. Spreading the ammunition throughout the vehicle significantly reduced the risk of a catastrophic detonation on a hit, which fed directly back into the tank's central design philosophy: keep the crew alive. The running gear surprised specialists. Rather than the torsion bar suspension used on essentially every contemporary tank, Soviet T-64s, American Abrams, all of them, the Israelis chose a coil spring system descended from the ideas of American designer J. Walter Christie from the 1930s. On the T-34, Christie suspension had already been considered a compromise by 1941, with designers planning a switch to torsion bars. The choice looked retrograde on paper, but it was deliberate. On the rocky terrain of the Middle East, where tanks routinely had to clear substantial boulders, coil spring suspension proved more suitable. It was heavier than torsion bars, but delivered better ride quality over broken ground and, critically, could be repaired in the field by the crew in a matter of hours. The suspension components were mounted externally on the hull sides, making them straightforward to replace. Torsion bars run through the interior of the hull. Fixing them required depot-level facilities. The external suspension also added a layer of protection against shaped charge warheads hitting the sides. Each side carried 6 road wheels and 4 return rollers. Early vehicles had rubber-rimmed wheels, though these were later abandoned. At a combat weight of 61 tons, the rubber simply couldn't handle the load and degraded quickly. Hydraulic shock absorbers were fitted at the front and rear stations. Drive sprockets with dual-tooth rings were at the front, idlers at the rear. Track width was 640 millimeters with 110 links per side. The heart of the tank was an American diesel, the Continental AVDS 1790, already well established in Israeli service on both the Centurion and the M48. For the Merkava, it was uprated to 900 horsepower and paired with an American hydromechanical transmission. Not particularly impressive numbers for a vehicle weighing over 60 tons, but the Israelis prioritized reliability and ease of maintenance over chasing performance records. The Merkava's combat debut came in June 1982 when Israel launched its invasion of Lebanon. The operation, codenamed Peace for Galilee, concentrated approximately 1,200 tanks along the border. Around 200 of them were brand-new Merkavas, about to prove themselves in actual combat for the first time. Facing them were Palestinian Liberation Organization fighters and Syrian army units equipped with Soviet hardware, T-55s, T-62s, and the veteran T-3485. The Syrians also fielded a number of T-72s, which were among the most capable tanks available at that time. On June 6th, Israeli forces crossed the border with heavy air support and pushed deep into Lebanese territory. The fighting was brutal. Merkavas operated in the thickest of it, storming fortified positions in urban areas, fighting along mountain roads and through valleys. Tank crews have to deal not just with enemy armor, but with infantry carrying anti-tank weapons in terrain that punished every mistake. By the end of the active phase of the campaign, the Israeli army had lost 52 vehicles of various types as total write-offs. The Merkava's numbers were telling. Only 7 tanks of that type were lost permanently. Another 27 were damaged to varying degrees, but returned to service. Among Merkava crews, the number of tankers killed in action was 0, not a single one. Among crews of other tank types, losses were substantial. Tal's core principle, crew protection above all else, had been validated in the hardest possible way. Even when armor was penetrated, even when vehicles were severely damaged, the men inside survived, thanks to the deliberate placement of the engine, fuel tanks, and armored bulkheads.
After the Lebanon War, military journals and specialist publications ran numerous accounts of Merkavas supposedly swatting Soviet tanks out of the air like flies. The most enthusiastically retold stories involved the destruction of T-72s, then considered the pride of Soviet tank design. Those accounts spread fast and hardened into legend, still repeated by military history enthusiasts around the world. The reality was considerably less dramatic. There were no direct gun duels between Merkavas and T-72s in that war. Every Syrian tank of that type lost during the conflict was destroyed not by Israeli tankers, but by crews operating TOW anti-tank missile systems. The composite armor introduced on Soviet tanks from the T-64 onward had been engineered specifically to defeat shaped charge warheads, and it performed that function well enough. Israel did field the M111 armor-piercing, fin-stabilized, discarding sabot round, which Israeli sources claimed could defeat the T-72's frontal armor at ranges up to 1,500 meters. But that claim was never tested against a T-72 in actual combat during 1982. The first Merkava's shortcomings deserve an honest assessment as well, and there were several. The most obvious was sheer size. The tank was large, visibly, unavoidably large, which made it a conspicuous target on the battlefield. Against the low silhouettes of Soviet-designed tanks, the Israeli chariot looked like a different category of vehicle altogether. Greater dimensions meant a higher probability of being hit, and no amount of armor could fully compensate for that. The second significant problem was the main gun. By the late 1970s, the 105mm caliber was already becoming obsolete. Western nations were moving to 120mm. The Soviet Union had gone from 115 to 125mm even earlier.
The Merkava's gun was gradually falling behind, and its effectiveness against future generations of heavily armored opponents was questionable. That problem wouldn't be resolved until the third variant, which received a 120mm smoothbore. The third weakness was overall hull protection. While crew survivability had been handled brilliantly as a system, the raw armor figures were modest for a tank of this class. 65mm on the turret, 60 millimeters on the upper glacis. After the Lebanon campaign, additional composite panels and reactive armor blocks began appearing on production vehicles and retrofits. It's worth comparing the Merkava briefly with the American M1 Abrams, which was developed during roughly the same period. The Abrams weighed less, carried significantly more capable composite armor, and used a conventional rear-engine layout. American designers never entertained the idea of building a troop compartment into their tank. They were building a pure fighting machine without compromise. The Merkava, by contrast, sat somewhere between a main battle tank and a heavy infantry fighting vehicle with a tank turret and tank gun, a machine built specifically around the particular character of Israeli warfare. Direct comparisons with tanks from other nations were never entirely fair to either side. The Israelis understood their first tank's limitations clearly and worked on them continuously. Even as the initial Merkavas were rolling off the line, the design team was already developing an improved version. The Lebanon War provided invaluable data on what needed fixing.
The second variant received substantially heavier armor, and first series vehicles were progressively brought up to a similar standard, recalled to the factory for additional protection, improved optics, and upgraded fire control. The Merkava evolved in plain sight, transforming from an unusual experiment into a genuinely formidable fighting vehicle. 61 tons of steel, built by people with no history in tank manufacturing, proved the central argument. Crew protection can and should be the design priority. No other tank in the world at that time could match its record for keeping crew members alive. 0 tanker fatalities inside Merkava hulls throughout the Lebanon campaign. That single statistic outweighed every criticism. Israel hadn't just built a tank. It had established a philosophy of tank design, one where the machine exists to serve the people inside it, not the other way around. The first Merkava became the foundation for an entire family of armored vehicles that still forms the backbone of Israeli armored forces today. From a strange hybrid cobbled together around a cut-up Centurion grew one of the most recognizable and debated tanks in the history of the armored vehicle. And it all started because a small country was refused the right to buy someone else's tank and decided to build its own.